Imagine Mars as a slim crescent while a small, foreign coma drifts across the page of space nearby. From that vantage, a handful of quiet orbiters look on, taking turns as the geometry allows, while Earth waits its moment after the Sun steps aside. We call this visitor 3 Atlas, the third interstellar object we've traced through our neighbourhood. It carries a faint reddish veil, a hint that its dust has been weathered for a long time. Its motion is unbound, a path that doesn't turn for home. The distance is comfortable and stays that way, so there is no hazard to fret over, just a chance to watch a traveller pass. On another screen, a star map shows a pale, chalk-thin curve arcing past the Sun. That line is not a loop, it is a crossing. Instruments that speak in light have already taken its measure. Hubble frames a compact glow around a nucleus we cannot quite resolve. Rubin's wide eyes found activity far from the Sun, when only the colder volatiles would stir. Justy, listening in longer wavelengths, reads a chemistry where carbon dioxide leads and water follows. Each piece adds calmly to the picture a natural comet. Only not from here. I like the tempo of this kind of watching. Spectra arrive as tidy bars, not dramatic scenes, and their meaning grows as the days pass. You and I can treat them like weather notes in a logbook. A little more water today, a steady breath of carbon dioxide, dust scattering light in a familiar way. The orbit says interstellar without asking for anything exotic. The measurements look for odd tugs, the kind that would whisper of forces beyond simple outgassing, and so far they mostly set limits that reassure more than they excite. Nothing in the motion requires an engine. Still, questions gather because that is what we do when something comes from far away. Could it be made and not grown? It's fair to wonder. The best reply is also the simplest. The light and the trajectory fit ordinary comet physics as we understand it. If future data show persistent pushes that can't be traced to jets or venting, the conversation changes. For now, the behaviour matches what cold ices do when sunlight wakes them. The calm answer is not a dismissal. It's a promise to keep checking. Step back with me to the bigger picture. Interstellar visitors are rare in our records, and each one offers a new angle. The first felt like a puzzle of shape and force. The second looked like a classic comet from another sun. And this one arrives with a visible coma and a chemistry that emphasises carbon dioxide. The trio doesn't form a simple pattern, but it does remind us that nature's work is diverse. 3 Atlas may be older than our familiar comets, rubbed by radiation for ages, and that long journey could explain its colour and texture without reaching for unusual causes. The viewing windows shape the story's rhythm. Early on, Earth sits at a poor angle, so we lean on spacecraft and observatories with better sightlines. Later, after the bright months, our ground-based telescopes pick up the thread as the glare fades. Post-perihelion, when the coma thins, we may glimpse the spin in the subtle rise and fall of brightness. A repeating rhythm would tell us about shape and rotation, and help separate thin, speculative ideas from sturdier ones. Even there, the first checks are natural shape, jets, and the way sunlight drives both. I keep a quiet secondary image in mind to hold all this together, a small control room late at night. Its lights dim, a printed spectrum taped beside the window, narrow bars stepping across pale paper. Outside, the dome moves a few degrees, then rests. Inside, the printout waits for a fresh line from the next exposure. That unhurried cadence is the promise here. We won't be rushed into grand answers. We will let the evidence arrive at a human pace. If you feel your thoughts drifting, that's fine. I'll take care of the details. I will point out the gentle facts first: the unclosed orbit, the steady distance, the reddish dust, the carbon dioxide speaking early so they can settle in without strain. When we test an idea that leans beyond the ordinary, I'll place the reassurance right beside it, like a handrail on a quiet stair. By the time Earth takes its turn with a clear view, you'll already know what to look for and how to weigh it. If you'd like, rest with me here and we'll follow the data together. Chapter 1. A third visitor from the stars. We're at a kind distance while a small interstellar traveller passes quietly, and I'll keep watch so you can rest easy. I want to start slowly, the way the sky reveals itself after you step outside at night and give your eyes a little time. The object we're following is called 3 Atlas, the third interstellar visitor we've recognised moving through our neighbourhood. Picture a faint glow drifting against a deep background, a smear of dust and gas wrapped around a core we can't quite resolve. Its track across the solar system is not a loop but a crossing, a path that arrives, curves, and continues into the dark with no intention of returning. Observation suggests the orbit is hyperbolic, a shape that tells us it came from beyond our sun's family. I like to place a simple sky map in the mind's eye, a white line arcing past the sun like a pencil mark. The radiant appears to point from a rich star field, a direction many charts label near the centre of the Milky Way's bulge. Yet that only tells us where the velocity vector seems to trace backward today. The larger truth is gentler. This visitor is not bound to us. It moves on a path carved by gravity alone, and it will go on after the momentary bend of its swing. It's likely that the path is retrograde and steeply tilted with respect to the familiar planetary plane, which helps explain why sightings favour specific geometries and why some vantage points are better than others right now. When a traveller like this arrives, it brings familiar questions. Is it natural or made? Comet or craft? Ordinary or extraordinary in a way that stretches the word? We'll take those questions as they come, placing careful handholds beside each step. For now, we let the light speak. The coma reads gently reddish, a tone often seen when dust has weathered in space for a long time. Early spectra gathered far from the sun showed little in the way of strong gas bands, which is normal at those distances. As it draws closer, different ices take turns waking, and the comet's breath grows more complex. You and I can hold a quiet comparison to the earlier guests. The first arrival tested our patience with an odd shape and a subtle push that sparked debate. The second behaved like a textbook comet and wore its dust and gas openly as it swept past. This third visitor shares traits with the second as far as we've seen. Though each of these journeys carries its own character, observations suggest the chemistry already leans toward carbon dioxide, with water signals rising as sunlight warms the surface. That mix is a calm thing to hear, an echo of what cold ices do when they begin to stir. I prefer to think about the cadence of the measurements rather than any single headline. A space telescope frames the glow and gives us size limits for the core without pretending to see what the glare still hides. A wide-field camera finds evidence of activity sooner than we might have expected, hinting that the colder volatiles began to sublimate while the object was still in the outer reaches. Ground instruments and orbiters check in when angles allow, and the data add layers rather than drama. It's likely that the absence of a strong, persistent non-gravitational push so far is just as informative as any brighter signal would be. Safety sits quietly beneath all of this. It matters that we say it clearly. The geometry keeps Earth well outside any hazard zone. The distance remains comfortable, and that will not change in a way that calls for worry. If you feel your mind drift towards scenarios, let it drift and then settle, knowing that the professionals who watch the sky build their models with care, and those models place this visitor far from any path that touches our world. We get the story without the fear, and that is a gift when you're listening at night. I also like to tuck a room into this picture, a control space with dim lights and a soft hum, where a printed spectrum is taped neatly beside a monitor. Someone has underlined a thin line that marks water's voice, and another that hints at carbon dioxide, and there is a note in the margin that simply says, "Steadier today? That is the tone I want for you." We follow the notes. We let the pattern emerge in its own time. We resist the urge to jump to the end of the book. As the traveller crosses the inner lanes of the solar system, the angles will change. New windows will open for instruments that were poorly placed at first, and familiar telescopes will take their turn. We will compare those views and look for agreement more than surprise, because agreement is often where understanding grows. If a genuine surprise arrives, we will greet it with the same patience and test it against the ordinary causes first. That is not skepticism for its own sake. It is kindness to the truth. In the end, what centers this chapter is a simple statement that needs no flourish. Observations suggest we are watching an interstellar comet behaving as interstellar comets do, with a reddish dust coma, a chemistry that fits cold ices, and a path that carries it safely past us. You and I do not need to solve the whole thing tonight. We need to know how to hold it, gently and without hurry, and to trust that the next measurements will refine the picture rather than overturn it. Keep that arc in mind, the pale line that crosses and goes on, and rest with the knowledge that it does not bend toward us. In the next chapter, we'll slow our gaze to the path itself, tracing how it moves when the key moments arrive, and why the timing keeps the story calm. Chapter 2 Orbit. Timing and safety. The path is open and unlooped, and it keeps a kind distance from Earth, so we can take our time with the details. Let's set the scene with a simple diagram, the sort a teacher might draw with a steady hand. The sun sits in the middle, and the planets trace gentle ovals around it, A single line enters from one side, curves near the sun, and leaves by another door without closing into a ring. That is a hyperbola, the shape of a path that belongs to the wider galaxy rather than our local family. From this shape alone, you can feel the logic this traveller is visiting, not joining, and its story with us has a beginning and an end rather than a cycle. Interstellar speeds can sound dramatic, yet the reality is patient. Motion at these scales is set by gravity's quiet arithmetic, and our perspective makes fast things seem serene when we spread them across months. It's likely that the inbound direction points roughly toward a dense region of the sky we often sketch near the central bulge, which is not a birthplace claim so much as a snapshot of where the past motion appears to trace. The orbit's tilt is high compared to the planetary plane, which is why one hemisphere often holds the better vantage during a given month, and why spacecraft stationed away from Earth can sometimes do more with the same light. Timing shapes both what we learn and how we learn it. Perihelion sits near the end of October, a moment when the sun's warmth reaches its strongest influence, and the visitor's turn is most pronounced. Before and after that date, the line of sight between the object and Earth changes in a way that either helps or hinders observations. Early on, Earth's angle is poor, so we lean on instruments that live in places with cleaner sight lines. Orbital mechanics is the quiet scheduler here, deciding who watches and when, and we simply follow the calendar it writes. There is comfort in the geometry. The missed distance stays generous, and the models agree on that point. You can think of it as a wide berth set by gravitational bookkeeping, a spacing that preserves our role as observers rather than participants. Observations suggest that the trajectory remains consistent with a gravity-only solution within the current uncertainties, which means no persistent anomalies are needed to explain the motion. That does not mean the data are perfect. It means the data we have cohere without strain. Because we are thorough, we also ask whether outgassing can nudge the path in small ways as the coma becomes lively. Comets breathe, and that breath sometimes acts like a mild thruster when it vents from one side more than another. The teams who fit orbits include terms in their models that can capture such effects, and they look for evidence of consistent departures from the simple gravitational prediction. So far, the limits are gentle and reassure more than they alarm. It's likely that any small pushes are either absent or balanced enough to hide within the current measurements. The viewing windows arrange themselves into a rhythm. As October begins, spacecraft with a favoured geometry may gather especially clear data, and as the sun moves out of the way later in the year, Earth-based telescopes pick up the baton. When you hear that one instrument's turn has ended and another's has begun, it is not a scramble but a relay. This is why a calm story can still be a complete one. Different eyes watch from different places, and the result is a composite picture that converges as the season advances. Safety remains the thread that never tightens. It's likely that Earth stays comfortably distant from the path throughout the apparition, and the models that set such expectations will continue to be updated as new astrometry arrives. If you find yourself wondering whether a new image changes that conclusion, know that distance predictions are among the most robust parts of these calculations once the arc of observations grows. In plain language, we would see any real hazard begin to form long before it mattered. And that is not what the data show. I imagine standing in a quiet room again, this time with a wall calendar pinned beside the spectrum printouts. A cross is marked near the end of October, and a small arrow in early December points to a window when Earth's angle improves. Nothing about the markings feels rushed. The team knows which nights offer the best chances, and they know how to use them without strain. This is the kind of planning that steadies the mind, because it replaces guesswork with a path you can trace with a fingertip. Comparisons help anchor expectations, so we glance at the earlier interstellar visitors again. The first was seen late and left quickly, its best moments of observation compressed into a short span. The second offered a more classical display, with strong activity and a trail that stood out even to modest instruments. This third visitor sits between those experiences, accessible in parts, reserved in others, and shaped by geometry more than spectacle. The lesson is consistent across the set. Nature gives us variety, and careful timing lets us hold that variety without force. There's a small test I like to keep near the end of this chapter, a check that carries forward into the rest of the series. If the path stays well explained by gravity alone, and if any outgassing nudges remain within the limits already suggested, then we keep the conversation rooted in ordinary comet physics. Should a coherent, directional deviation grow beyond those limits later on, we will examine it with fresh care. Even then, The first causes to check will be natural jet geometry, rotational state, and how sunlight and spin combine to move material out into space. Let the diagram in your mind settle one more time. The sun glows, the planets circle, and one chalk-thin line enters, turns, and departs. Our role is to note where that line crosses our page and when the angles favour a sharper look, and to remember that the wide berth keeps us in the posture of calm observers. As we turn the page, we will move from the path to the traveller itself, and consider how big the core might be, and how the dust around it turns a point into a soft, teardrop glow. Chapter 3, Size Limits and the Dust Cocoon. We're still at a safe, steady distance, and I'll guide the picture slowly so nothing feels rushed. Let's stand beside the instruments for a moment and imagine what they see. The object is wrapped in a soft envelope of dust and gas, a pale shape that looks almost like a teardrop when the sunlight pushes from one side. The true body, the solid heart of it, stays out of reach for now. That isn't a failure, it's the natural result of distance and glare. The brightest part of the glow is where the core should be, yet even our sharpest eyes do not tease out an edge. Observation suggests the nucleus is smaller than a modest mountain and remains unresolved within the haze. That single line helps us hold the scale without forcing the details. When I think about size, I think about what we know and what we don't need to guess. A limit is still knowledge. It sets a ceiling and says, no larger than this, which already tells us a lot about mass and surface area, about how sunlight might heat the crust, and about how quickly fresh ices could answer that warmth. It's likely that the combination of distance and an active envelope is what hides the core, not some unusual stealth of material. We've seen this before with other comets. The halo easily outshines the stone at its heart. The dust cocoon is more than decoration. The pattern of brightness, slightly thicker toward the sun and feathering away from it, hints at the direction of the flow and how grains and gas escape together. If you were to sketch it with a charcoal stick, you'd press a little harder on the sunward side and let the shade trail gently away. That shape, simple as it is, anchors the idea that sunlight drives the show. The nucleus warms, gas lifts, dust follows. A breeze of particles streams outward until it thins into the background of space. I like to picture a quiet lab table with a stack of printouts. Hubble contributes the crisp silhouette of the glow, its resolution carving a narrow point spread where the core ought to be. Rubin adds a wide-field context, revealing that activity began far sooner than we might expect for water alone. And the longer wavelengths from space-based spectrometers bring the chemistry, which we'll savour more fully in the next chapter. For now, we hold the geometry and the outline, a compact envelope, a hidden core, a shape that tells you where the light falls. There's comfort in the modesty of these claims. We don't need perfect sharpness to draw sensible boundaries. Observation suggests the overall brightness fits what you'd expect from a small body venting at a measured pace. The lack of a crisp edge around the nucleus is not a puzzle to solve tonight. It's an invitation to be patient as the viewing geometry improves and as the comet rounds the sun. After perihelion, when the ambient glow thins and the line of sight shifts, the same instruments may be able to tease out periodic flickers that hint at rotation. That is a later gift, and we don't need to reach for it yet. If your thoughts wander here, that's all right. Let them float for a few breaths. I'll keep watch on the scale of things. When we say small, we are speaking relatively. In the language of comets, small can still mean wide enough to hold a complicated surface, with fissures and planes, with pockets where heat pools and vents open. It's likely that the side facing the sun shows a different pattern of activity than the night side, and that any slow turn will move those patterns around in ways that mimic gentle changes in light. None of that is unusual. None of that asks for anything other than sunlight and volatile ices. I want to be clear about another detail a dust cocoon can hide as much as it reveals. The brightness we measure is a mixture of reflected sunlight from grains and faint fluorescence from gas. Sorting those contributions is a careful art, done with filters and models that tell us how much light the dust should return for a given amount of mass. That is how we begin to estimate how much material is flowing off the core. It's likely that the dust is made of dark, weathered particles, which helps explain the subdued glow and the warm colour we'll discuss soon. The important thing is that the counts add up without strain. Does this mean we already know everything we need to know about size? Not at all. It means we hold a reasonable ceiling and a sensible path forward. As the comet moves, we will listen for the tiny, repeating dim and bright rhythm that rotation can imprint on the light. If we catch it, that rhythm, once modelled, can constrain the shape and tilt of the core and help us translate the brightness into cross-section, paired with improved resolution later in the season. That gives us more than a ceiling. It gives us a sketch we can trust. I keep a second image nearby to steady the mind, a thin strip of atmosphere over a dark horizon. The kind you see from space when the world rolls under a spacecraft. That strip glows softly because light has somewhere to scatter. The comet's dust cocoon is like that in spirit light finds particles and spreads, and the outline becomes gentle instead of sharp. I say in spirit because the physics is different, but the way your eye understands the glow is similar. It helps to remember that we're not supposed to see the core clearly yet. The hazy veil tells us it's doing what comets do. Now, because this series invites the question, I'll place a hand on the concern that sometimes rises here. Could a hidden core conceal something engineered? The honest, careful answer is simple. Observation suggests nothing in the size limits, or the shape of the cocoon requires any exotic cause. The envelope matches ordinary activity under sunlight. If later data reveal a persistent, directional push that defies outgassing, or a shape that cannot be reconciled with natural processes, then the conversation would change. For now, the mildness of the profile is an ally. It keeps us grounded. Let's bring the chapter to its centre. We have a compact glow, a nucleus still tucked behind its own outflow, and a shape that leans toward the sun and opens gently away. The scale is bounded by upper limits that already guide our expectations for mass and heating. The activity appears steady rather than violent, and the balance between dust and gas looks familiar for an object waking from cold. It's likely that later measurements will refine these statements without flipping them. Rest with that for a moment. The picture is incomplete in a pleasing way, like a sketch with the lines blocked in and the shading still to come. We'll add that shading next by staying with the light itself, shifting from outline to colour, and reading the first spectra for what they say about the dust and the earliest gases. Chapter 4, Colour and the First Spectra. We keep a patient pace, and I'll place a reassurance beside each new idea so the story stays calm in your hands. Light carries more than brightness. It carries character. When we talk about colour here, we mean how the dust and gas shape the light, tilting it toward the warm end by a noticeable amount. Under ordinary sunlight, a clean, bright scatter would give a fairly neutral hue. But dust that has travelled for ages and sat in radiation for long stretches tends to develop a deeper tint. Observation suggests this visitor wears a moderately red veil, which fits a history of long exposure rather than anything unusual in the present moment. That's our first anchor in this chapter. The colour aligns with what space-weathered grains often show. Spectra are the next level of reading, and they arrive as tidy sequences where small valleys and peaks line up with specific molecules. Early in the approach, when the sun's warmth had only begun to lift the coldest materials, the spectra did not flaunt strong gas bands. That quiet start is normal at long distances. Dust often leads the show there, because even a gentle stir can shake loose small grains, while the warmer volatiles wait for stronger sunlight. As weeks pass, the bars on those charts begin to hint at water's voice, and other lines join with soft confidence. It's likely that carbon dioxide speaks first and clearest, with water following as the surface warms. I want you to imagine placing those charts side by side. In one, a camera records the overall colour, shifted toward the warm. In another, a spectrograph draws slender traces where particular molecules absorb or emit. The agreement between them is quiet and satisfying. The colour hints at dust that is dark and seasoned. The spectra tell you which gases are stirring and when. Taken together, they steer us away from dramatic ideas and into the comfort of known physics. Sunlight warms. Ice's answer. Dust reflects with a tint shaped by age. Sometimes people hear redder than average and feel the spark of mystery jump. Let's hold that spark but seat it properly. A stronger tint does not mean paint or metal. It often means small grains with complex carbon chemistry on their surfaces, shaped by time and radiation. Observations suggest that the spectral slope, the measure of how the brightness changes from one band to another, falls in a range that has cousins in the family of comets and distant small bodies. The siblings aren't identical, but they share traits. Variety is the rule in nature's workshop. When I say first spectra, I'm also saying first draft. The demand for patience is built into the method. Early exposures are shallow, because the object is faint and far. Later ones grow deeper and cleaner as geometry improves. That is why every sober claim in this chapter is made with calm phrasing. It's likely that the main trend carbon dioxide first. Water later will persist. while the fine details sharpen. If you hear a single measurement proclaimed as definitive this early, make room for the possibility that the chorus of instruments will revise it gently as the dataset grows. Let's spend a paragraph on how dust scatters light, because that is where colour begins. Grains are not little mirrors, they are irregular, porous, and complex when sunlight hits them. Some wavelengths scatter a bit more efficiently than others. Multiply that by the grain size distribution, the surface chemistry, and the line of sight through the coma, and you get the tint we measure. None of this requires special materials. It is the ordinary magic of light interacting with common solids, written across a long journey that darkens and warms the tone. Now, because this series honours the question that follows us, we'll place a what-if exactly where it belongs. What if the pronounced colour and the early chemistry hinted at something engineered? The reassurance sits right beside it. The same colour and chemistry are readily produced by natural grains and ices, and the earlier spectra show nothing that demands an artificial explanation. It's likely that as activity rises near the sun, ordinary processes will add water and other familiar signatures to the mix, in a way that further softens the need for anything exotic. I like to keep our metaphor budget simple, so I'll use just one picture to anchor the feeling of the spectra. Think of a music box that plays the same gentle tune whenever you wind it. At first, the notes are faint because the room is noisy. As you draw closer, the melody is clearer. The melody here is the pattern of lines carved by carbon dioxide, water, and a few other companions. The tune is familiar. It tells us we're listening to ices and sunlight, not to a new instrument. The colour also helps constrain the dust itself. Warmer tints can point to fluffy aggregates, and they can mark surfaces that have been baked and altered. Later, when we pull polarimetry into the conversation, we'll test those ideas with the way light's polarization flips and deepens near certain angles. For the moment, we stay with colour and spectrum, because they're already enough to situate the object in a known landscape. Observation suggests that the dust population is not outlandish. It looks like what you would expect from a body that formed in cold conditions and spent a long time between suns. You may feel a drift of curiosity here. How soon will we see the waterlines grow bold? And will other species join the chart? That drift is welcome. The schedule is set by the orbit, and the watches are kept by a group that understands the cadence. When Earth's angle improves, more telescopes will add their pages to the record. The goal isn't to catch a surprise, it's to watch the expected trend unfold, so that any true oddity stands out against a well-measured baseline. One more anchor before we close this chapter. Observation suggests that early spectra align with a coma, where carbon dioxide is actively lifting from the surface, while water wakes more slowly. It's likely that this ordering reflects the depth of heating and the way sunlight penetrates the topmost layer. That explanation is modest and satisfying. Different ices respond at different thresholds, and the pattern we see is exactly the one those thresholds predict. Hold that in your mind as a quiet conclusion to tonight's reading of the light. The colour is warm, the early gases are in character, and the lines on the charts carry the same calm melody you'd expect from common ices stirred by a new sun. In the next chapter, we'll let the light twist a little, turning to polarization and the grain clues that hide in the way brightness changes with angle. Chapter 5, Polarimetry and Grain Clues. We're still on safe footing, and I'll guide you gently through how light changes when it scatters from quiet dust. Polarimetry sounds technical, but the feeling of it is simple. Light carries a preferred orientation after it bounces from tiny grains, and that orientation changes with the angle between the sun, the comet, and us. When we measure how that orientation rises and falls with angle, we draw a curve that acts like a fingerprint. Observations suggest this visitor's curve dips more sharply than is common, and then rises sooner, a pattern that expands the range we've seen among comets, rather than breaking the mold. That dip is called the negative branch, and though the phrase sounds stern, it is simply a way to note that the orientation flips in a predictable way at small angles. I like to picture the experiment as a turntable, not in a flashy way, but as a quiet device that lets you sample different angles with patience. You place the comet at the centre in your mind and walk around it with a lantern, pausing to see how the glow changes. As you move, the curve you track tells you about the dust, how porous it might be, how large the grains are, how rough their surfaces feel to light. It's likely that the sharper dip here hints at fluffier aggregates, the kind that look like tiny snowballs made of even smaller pieces. That interpretation is not sensational. It is a steady inference we have made before for other comets with similar curves. Colour and polarization often travel together, and they do so here in a way that helps the story stay grounded. The coma's warm tint tells us the grains are dark and seasoned, and the polarization curve suggests those grains are not solid pebbles but airy clusters. Think of a loose foam rather than a clean crystal. The foam picture is modest and useful because porous grains increase the path that light takes inside them, and the internal wandering shapes both colour and polarization. Observation suggests the two signals cohere a redder veil, and a deeper dip belong to the same family of dust behaviour. Now, it helps to explain the little hinge in the curve, the place where the sign flips. The inversion angle is where the negative branch crosses to positive, and in many comets the crossing happens at a familiar range of angles. In this case, the crossing appears to come a bit earlier. That earlier crossing is interesting in the way a dialect is interesting. It stretches what we think of as ordinary without leaving the language. It's likely that the internal structure of the grains and the mix of sizes shift the crossing point, just as we would expect from well-studied scattering models. If we step back from the curve and look at the scene as a whole, the measurements feel unhurried and consistent. Different instruments, using different filters, reproduce the shape within their limits. You and I do not need to memorize the terminology to keep the idea straight. Light comes in, meets airy, weathered dust, and leaves with an orientation that tells us about that meeting. The deeper dip and the lower crossing live comfortably inside the wide room that nature has already furnished for comet behaviour, because this series keeps a hand on the question many people carry. We'll place a what-if right where it belongs. What if the unusual dip or the early crossing hinted at manufactured materials? The reassurance sits beside it. Scattering quirks like these are common in comets with porous grains, and nothing in the curve demands anything artificial. Unusual here is the same as distinctive, not the same as unnatural. It's likely that as the comet moves through changing angles and as the dust cloud evolves, the curve will shift in familiar ways that strengthen the natural reading. There is another quiet reason the curve matters. Polarization can help separate light from dust and light from gas, because those components polarize differently. When we know which part of the glow is dust, we can better estimate how much material is leaving the nucleus, and how the size distribution changes with time. That, in turn, anchors our sense of how rapidly the surface is losing mass, and how jets might develop as patches warm and vent. Observation suggests the dust share of the brightness is substantial here, which pairs neatly with the warm colour and the compact, sunward thickened shape you and I pictured earlier. I keep the metaphor budget light, so I'll use just one more picture to hold the idea. Imagine a lace curtain in a window, and imagine sunlight crossing it at a slant. The pattern on the floor shifts when you step to one side. Nothing about the curtain is exotic. The geometry and the texture do the work. Polarimetry tells us about the lace how open it is, how its threads tangle, and the changing pattern on the floor is the curve we draw with angle. The comet's curtain seems a little finer and more open than average, which is interesting and still ordinary. As the season advances, we'll watch for small, natural changes. Fresh grains may be lofted as the surface warms. The fraction of larger to smaller pieces may drift as jets start and stop. It's likely that such changes will soften the dip or move the crossing a bit, and those shifts will help confirm the airy aggregate picture. If there is rotation that brings different regions into sunlight, the curve may show gentle ripples from night to day transitions, and that will help us tie the light to the surface in a more precise way. Even without those refinements, we have enough to carry forward. The coma's warm tone, the pronounced dip, and the earlier crossings sing the same tune about dust that is dark, porous, and shaped by long exposure. The measurements fit into the natural diversity we already know, and they offer no pressure to invoke anything beyond sunlight, ices, and the complicated ways that small grains meet light. Observation suggests that ordinary scattering physics explains the pattern with room to spare. Let that settle like a map folded neatly back into its sleeve. We have a fingerprint that widens the family album without changing the faces. In the next chapter, we'll turn from how light twists to when the coma first stirred, and we'll trace the early wake-up that began out in the cold where carbon dioxide takes the lead. Chapter 6, Waking Up in the Cold. We're still watching from a kind distance, and I'll trace the earlier stirring so the timeline feels calm and clear. Comets do not all wake at the same time. Different ices listen to different levels of warmth, and some begin to sublimate while the sun is still only a pale lantern in the distance. For this visitor, evidence of activity appears in images taken before the official discovery. tucked into surveys that scan the sky every clear night. Observation suggests the coma was already present beyond 6 times Earth's distance from the Sun, which is the realm where carbon dioxide can lift on its own while water stays mostly quiet. That statement carries a lot of comfort, because it ties the wake-up to well-known thresholds rather than to novel mechanisms. The pre-discovery frames serve 2 gentle purposes. First, they extend the timeline backward, which strengthens the orbit and reduces the wiggle room in where the path leads. Second, they show that the object was not dark and dormant until the last moment. It was breathing softly even in the cold, which is what you would expect from a mixture that includes volatile carbon dioxide near the surface. It's likely that grains were being lofted slowly at that stage, producing a compact glow without dramatic jets. A wide-field survey with sharp eyes adds context that makes the early activity easier to hold. A diffuse envelope can be seen where earlier charts showed only a point, and that envelope bends slightly toward the Sun the way it so often does. The scale is modest in absolute terms and still vast when you remember that even a thin cloud spreads across immense distances in space. What matters most is the pattern, a sunward thickening and an anti-sunward feathering. The same geometry you and I traced when we talked about the dust cocoon. Now we can lay a second anchor without hurry. Observations suggest the astrometric fits stay aligned with a gravity-only path within the current limits, even when the growing coma adds a little extra blur to the measurements. Teams fit for small, consistent departures that might signal a net push from uneven outgassing, and those checks return values that lie inside the lines rather than beyond them. It's likely that any tiny nudges either cancel over time as different regions vent or remain too gentle to matter at this stage. That point deserves a moment of clear air. Non-gravitational acceleration is not a mysterious force. It is the bookkeeping outcome of jets and vents that push more on one side than another. When those jets have a preferred direction and persist, the path can show a subtle drift. When they are patchy or alternating, the pushes can cancel to within our ability to measure. For this visitor, the early ledger reads as a set of reassuring limits. The story stays inside the frame drawn by gravity. Where most comets live their lives unless something strongly asymmetrical sets in, the early wake-up also tells us about structure under the surface. If carbon dioxide answers first, then the pathways for that gas are shallow enough to meet sunlight with minimal delay. That sets the stage for how the coma will evolve closer in. As the top layer warms, water will join the breath, and the dust flow may thicken. It's likely that regions with slightly different textures will alternately dominate as the body turns, and that alternation will leave a soft pulse in the light that observers can measure after the glare of perihelion fades. I keep the memory of a control room close as we talk through this phase again. Someone scrolls back through survey data and circles a faint haze that was easy to miss the first time. Another person adds that frame to the orbit solution, and the arc grows longer. The small addition carries a large reward. Because orbits love time, the longer you watch, the more gently the uncertainties shrink. There is nothing dramatic in this work and everything satisfying. The path steadies, the calendar hardens, instruments can plan with confidence rather than hope. Early activity at such distances invites a familiar what else question. Even when the chemistry already has a good answer, could the wake-up be driven by an unusual process unknown to us? The reassurance is quiet and close. Carbon dioxide is a ready worker in the cold, and the observed onset matches the expectations for that ice under sunlight. We leave room for learning and still keep the explanation anchored to the ordinary. It's likely that as the object moves inward, the pattern will unfold in the same order many comets have displayed, with water becoming more prominent and dust production waxing with it. Another benefit of the pre-discovery detections is the way they blend with newer, sharper images taken after the announcement. Early measurements show the envelope. Later ones refine its shape and brightness, and together they tell a single story about a slow, steady climb in activity. When you hear someone mention that a large facility provided serendipitous data, it means the object happened to pass through the field while the instrument was looking elsewhere, and the result becomes part of the record. Chance favours the prepared observer, and sky surveys are the most prepared observers we have. We should also note how these early signs fold into the safety picture you and I care about. The extended timeline lets teams check whether any outgassing pushes are biasing the orbit in a way that would shrink the miss distance. The answer remains calm, the distance stays generous, and the path remains clean of any crossings that would change that. Observations suggest that the model updates nudge small parameters and leave the broad shape untouched, which is exactly what we hope to hear as data improve. As the calendar moves forward, vantage matters. Before Earth's view improves, spacecraft and observatories with better angles carry more of the load. Later, ground-based telescopes take their turn when the sun's glare no longer sits in the way. It's likely that a few windows stand out for especially rich spectra, and for timing that favours rotation studies. Those windows will give us the chance to test whether the early carbon dioxide-led behaviour transitions into a more balanced mix, and whether any jets show a preferred direction that could, at last, lift a small non-gravitational signal above the current limits. Let the picture close in the same gentle tone with which it opened. The coma woke in the cold, as carbon dioxide does when it sees even a little warmth. The orbit gained confidence from frames that were waiting quietly in the archives. The checks for subtle pushes remain inside comforting bounds. Nothing in this phase presses us toward anything beyond sunlight and volatile ices working through familiar physics. In the next chapter, we'll let water speak more clearly, follow the faint fingerprints that mark its presence, and step to a vantage that gives us a cleaner look while Earth waits its turn. Chapter 7, Water. Oh, and a planetary vantage. We're still in a calm geometry, and I'll keep a steady pace while we let water speak and borrow better eyes when Earth's view is poor. There's a quiet satisfaction when a comet begins to murmur in familiar tones. Earlier, we listened as carbon dioxide took the lead, a natural choice in the cold. Now, softened by distance and warmed by approach, water begins to join the voice. We don't touch the nucleus directly. We listen for its echoes. One echo is the faint presence of OH, a fragment that appears when sunlight breaks water apart. Observation suggests this fragment grows more confident as the path bends sunward, a sign that water ice near the surface is starting to breathe. That phrasing is gentle on purpose. The signal doesn't rush in, it unfolds, as if the comet is reading lines it has known for ages. When we say water production, we mean the rate at which molecules become part of the coma and drift into space. The numbers behind that phrase are built from patient integrations, from spectra where small bands rise just above the noise, from repeated measurements that agree more often than not. It's likely that the curve is rising with time, not in a dramatic leap, but as a steady incline that models have long expected. The same sunlight that brought carbon dioxide awake now reaches shallower layers and wakes water too, first in patches that face the light and later in regions that roll into view as the body turns. Because Earth is not ideally placed at this moment, the story relies on vantage points that aren't ours. Picture Mars as a slim crescent off to one side, small spacecraft circling it like lanterns on a balcony. From that balcony, the angle is cleaner, the glare reduced, and a few instruments can do what our ground telescopes will do, later measure the spectrum where OH hides, track the dust brightness where jets might show, and pin down the timing of changes as the heating grows. Observation suggests this coordinated watch is already paying off, stitching together a timeline that would be patchy if any one platform had to carry it alone. I like the rhythm of shared duty. One observatory takes a turn, then another. No single instrument must do everything. When Earth falls into a poor angle, a rover in orbit around Mars, or a space telescope free of weather and daylight, steps into the light instead, it's likely that this relay will produce the kind of curve we depend on later, when we want to compare how quickly water rose relative to carbon dioxide and dust. Those comparisons make or break many of the big ideas we test, not because they're flashy, but because they force the details to align. Let's place a clear anchor, then let it rest. Observation suggests that OH detections are becoming firmer with time, and that the absolute brightness in water-sensitive bands is trending upward as the comet approaches the sun. That's a classic signpost. It doesn't foreclose surprises, but it sets a baseline against which any surprise must rise. If anyone tells you water is silent here, they're either too early in the sequence or standing at a vantage that hides the whisper. Shift the angle, and the whisper becomes a tone you can trace with confidence. You and I can imagine the way these measurements become maps. A spectrograph breaks light into narrow slices, and software draws each slice as a thin lane across a page. When the lane where OH lives begins to brighten in step with the comet's approach, we mark that page. When a camera tuned to a dust-sensitive band shows a soft plume that leans away from the sun, we add an arrow and a date. When a radar or an optical timing method finds a small, repeating rise and fall, we circle the region of the light curve and add a question spin, or jet, or both. Each mark is small, but together they give shape to a season. An important caution fits here. Even with better vantage, Water can be shy while the sun is still low in the sky from the comet's perspective. Dust often outruns it in visibility, which means you can easily overrate dust and underrate gas if you rely on a single band. That's why teams spread the work across instruments and wavelengths. It's likely that the parts of the coma we see in visible light are dust-rich at first, and the parts we infer from ultraviolet and infrared are more balanced. Later, as heating deepens, the balance shifts, and the bands join in equal measure. The Mars geometry is not a magic trick. It's good fortune and careful planning meeting in the middle. If a spacecraft in that neighbourhood can point long enough, it can watch the objects sweep across a clean patch of sky and gather data without the wandering bright streaks that ground observers fight near dawn or dusk. Observations suggest that these intervals have already tightened the orbit solution and refined the activity curve. That means when Earth's turn comes, we will not be starting from scratch. We will be checking a score already written in a clear hand, because this series promises to carry each curiosity with care. We acknowledge a question that sometimes floats up when new vantage points enter the story. Do different eyes complicate the picture? The answer is gentle. Different eyes simplify it, as long as their measurements can be brought into the same frame. It's likely that some small adjustments are needed: calibrations, filter translations, timing tweaks, but the reward is a curve that spans more angles and more hours than any single observer can collect. That breadth is the friend of truth. It blunts the quirks of any one method and lets the shared signal shine. I keep a single image beside all of this. Nothing grand, a notebook lying open near a window. Lines filled with small, even handwriting. On one page, a list of times and instruments. On the next, short phrases: rising, dust plume steady, angle improves in December. It's not a storyboard for drama. It's a ledger for patience. Every time a line is added, uncertainty shrinks a little. Every time two lines agree, confidence climbs without any need for declarations. So where does this leave the big question, the one that asks whether something engineered could explain what we see? It leaves that question unchanged. Water joining after carbon dioxide is the pattern that ordinary physics writes, and the vantage sequence only sharpens that writing. Observations suggest the motion remains consistent with gravity and modest venting. It's likely that any future claims of odd propulsion must cross a higher bar now, because the baseline trend is clearer, and because more eyes can test any deviation as soon as it appears. Let's give the sense of schedule one more gentle turn. The next months bring a swing past the sun and then a thinning of the glare. When the coma calms a little, subtle brightness rhythms can emerge. Those rhythms will either echo familiar rotation and jet patterns, or they will stand apart in a way that demands deeper thought. Either way, the water we hear now is the first part of a theme that will run across the latter pages. It anchors the comparison we make later. When we set this visitor beside the others we've known, rest in that. The voice of water is rising. The balcony view from Mars and nearby space is steadying the record, and Earth will take its turn when the light is kind. In the next chapter, we'll place this traveller next to its two predecessors and see how the family resemblance and the differences settle the mood of the story. Chapter 8 setting 3i beside 1i and 2i. We stay with the gentle facts first, and I'll walk you through the comparison in a way that keeps the edges smooth. Comparisons are invitations to breathe slowly. They help us hold variety without reaching for drama. We have met two interstellar visitors before. The first, small and oddly behaved, left quickly and stirred debate with a subtle, persistent push and no obvious coma. The second was more straightforward, wearing a classic coma and tail, and it passed like a familiar comet from a different address. The third, the one we follow now, carries its own character. Observations suggest it belongs closer to the second in presentation, with a visible coma and dust that scatters light in ways we recognize. It's likely that the chemistry, so far, leans toward carbon dioxide in a way that sets it apart gently from many local comets, without asking for anything outside natural diversity. Let's make the picture simple. Place 3 panels side by side. In the first, a starlight point stretches briefly and then remains frustratingly clean of gas. In the second, a robust coma blossoms and a narrow tail forms, textbook in its poise. In the third, a compact, teardrop glow surrounds an unresolved core, and the early spectra tip the balance toward carbon dioxide. With water rising in time, if you look only at silhouette, you would set the third near the second. If you listen to chemistry, you hear a new mix, but not a new language. This middle ground, familiar shape, distinctive chemistry is the heart of our calm reading. It means we do not need the hard-edged debates that swirled around the first visitor. It also means we do not simply copy the second story and paste it here. Observations suggest the reddening is stronger this time, and that the polarization curve dips more deeply and crosses earlier, all of which point to dust that is fluffy and dark, shaped by long radiation exposure. It's likely that age and journey length play roles in that, and those roles are ordinary. When a trio collects on a shelf, people look for a pattern. The temptation is to draw a line where only a cloud belongs. The line would say, the first is odd, the second is typical, the third is halfway. The cloud says, nature's workshop is wide. The value of the third is not that it splits the difference. It is that it expands the frame without breaking it. We now hold examples of a naked traveller, a classic dusty visitor, and a visitor with a compact, reddish shroud and a carbon dioxide tilt. None of these, taken alone, can tell you what every interstellar object will look like. Together, they tell you that variety is the rule, and that careful tests matter more than categories. A few practical lessons fall out of this comparison. First, early detection at large distances matters, because it gives you time to watch cold ices wake and to see whether dust leads or lags. Second, a strong coordination between space and ground assets matters, because vantage decides who can see what and when. Third, the search for non-gravitational pushes must come with patience, because even a truly odd signature can hide beneath the coma's blur until the right phase of the orbit uncovers it. Observation suggests the third case benefits from that patience already. With push limits that comfort the cautious, it's likely that those limits will tighten after the sun is past and the glare thins. Now, because the question is always in the room, we set a what-if on the table and pair it with its reassurance. What if this visitor's strong carbon dioxide and deep, reddening whisper of processing that is not natural? The reassurance is kindly those same traits arise in ordinary ice and dust physics under irradiation and gentle heating. The comparison to the second visitor helps here. The second showed a more water-forward chemistry and a less intense tint, and yet no one needed an exotic cause to explain it. In the third, we shift the sliders and still remain within the frame of known behaviour. The first visitor remains a special case in one respect, because its faint push, if taken at face value, urges models to include a non-gravitational term without a visible gas source. That is where debate lives. But the third traveller doesn't echo that note. Observations suggest its path to date stays near the gravity-only line, and the wake-up sequence mirrors the expectations for carbon dioxide and water in turn. It's likely that even if a tiny push appears later, the presence of a healthy coma and evident vents would offer a ready explanation before any stranger idea is asked to stand. In setting one object beside another, it's important not to let differences eclipse the shared roots. All three arrived from beyond our planetary family. All three move on open paths. All three tell us that the space between stars is not empty, and that the fragments wandering there carry the histories of their own birthplaces. By comparing their colours, comae, and motions, we are not voting one explanation up or down. We are drafting the first pages of a field guide that will take many entries to complete. The third entry reminds us that chemistry can surprise without alarming, and that a compact, active coma can hide a small core without games. I keep a single image in mind to avoid the tug of certainty, three small stones set in a shallow dish of sand. One is polished smooth, one shows a dusty bloom, one looks dark and softly textured. They all belong in the same dish. The differences are interesting because they teach you what to look for next time. That's the power of comparison. It trades loud claims for useful attention, and it makes the next discovery easier to place the moment it appears. A quiet benefit of putting the third beside the second is practical forecasting. If the second taught us how post-perihelion light curves can expose rotation once the coma thins, the third invites the same test. If the second's tail structure told us how jets and spin-shape dust streams, the third's compact plume will give us a concentrated version of the same lesson. Observation suggests that a post-sun swing will bring the needed clarity. It's likely that the late-season data will settle whether the dust release favours a few regions or a global simmer, and whether any gentle push rises above the limits set so far. Finally, comparisons help the mood as much as the models. They remind us that natural explanation is not a dismissal, but a working hypothesis that has earned its place by fitting many lines at once. They also remind us that being open to revision doesn't mean living in suspense. Instead, we carry a clear, calm picture forward and make space for changes if the evidence insists. In that spirit, The third traveller takes its seat. It is neither a copy of the second nor a shadow of the first. It is itself, and that is enough to keep the story honest. Let that be the closing breath for now. We've set the present visitor beside its kin, and found a balance between likeness and difference that keeps our footing sure. In the next chapter, we'll turn from resemblance to roots and ask, with care and patience, where in the wider galaxy a traveller like this might have begun its long, quiet journey. Chapter 9, where might it come from? We're still on even ground here, and I'll carry the map slowly so the possibilities feel roomy rather than rushed. Origins are stories we tell with motion. When we ask where this traveller began, we start with the direction it arrived from and how its path tilts compared with the easy plane where most planets circle. Observation suggests the inbound direction points toward a dense star field, and the path runs steep and retrograde to the planet's roadway. That geometry already says not from here with quiet certainty. The harder question from which part of there asks for patience, because a path that crosses our system only once is a thin clue to a long history. To make sense of the sparse clues, we lean on a set of gentle tools. We look at the incoming direction and ask how that compares with the motions of different stellar populations in our galaxy. We track how the object's speed and tilt line up with what you'd expect if it were nudged from a distant reservoir by the slow shuffle of planets in another system. We weigh how radiation and time can deepen colour and loosen grains. It's likely that a few of these indicators point to great age, not as a dramatic revelation, but as a calm inference drawn from the way the dust looks and the way the light behaves. There's a practical step that helps the story breathe, extend the record backward. Pre-discovery images found in wide surveys lengthen the observation arc and make the present path crisper. That longer arc narrows the family of possible past directions, even if it never becomes a single, sharp line back to a single birthplace. Observation suggests those earlier frames already nudged the motion into a cleaner solution, and trimmed uncertainties that might otherwise have grown like weeds. A longer arc is not only a better fit, it is a guard against wishful thinking. Another line of reasoning considers the galaxy's layered structure. Some stars, and the small bodies that form around them, belong to an older, thicker disk that moves with a slightly different rhythm than the thin disk where the sun sails. A few analyses read the visitor's motion and see echoes of that older population. What if this traveller is very old, launched long ago from a system that now orbits the galaxy on a broader, slower loop? Reassurance age does not make anything ominous. It mostly deepens the expectation of weathered dust and a reddish tint, which is exactly what the light already suggests. When you and I talk about ejection from a home system, we're not imagining violence beyond the ordinary. A small body can be eased outward by a planet's gravity and, over many passes, slip free entirely. Some are tossed early, when giant planets shift position. Some are released late, after many quiet orbits. The result is much the same. A small survivor is set adrift between stars. It's likely that our traveller follows that common script. Nothing in its behaviour so far asks for new chapters or special actors. Colour and texture fold into this origin story in a soothing way. Grains that spend long intervals under radiation tend to redden and to grow porous. Polarization curves that dip deeply and then pivot early fit airy aggregates rather than compact chips. Observation suggests that this visitor's dust behaves like that, dark, loose, and seasoned. That behaviour doesn't point to a single birthplace, but it does sketch a long timeline. A long timeline makes any specific origin claim feel provisional, and any broad origin class feel plausible. Backward tracing an orbit through the solar system is straightforward. Tracing it through the galaxy is not. A brush with a planet here introduces a small change there. A pass through a region with different stellar density introduces another nudge. Over long spans, tiny uncertainties become wide fans. That is why the mature tone here is modest. We can say where the motion leans. We can say what the dust hints. We can say which families in the galaxy move this way more often than others. We can't say which star flung it or which backyard it once crossed, because the mood of this series is steady. I'll place a hand on a concern that sometimes appears when people hear older population. Older does not mean brittle. It means time had its patient way, and surfaces adapted. It's likely that older bodies carry thicker skins on their grains and a stronger tint. It's also likely that when such bodies pass near a new sun, the first chemistry to stir may be the kind that wakes in gentle warmth, which fits the early carbon dioxide signs you and I have heard. The clues fit together without drama. There's also the practical wisdom that comes from comparing with the earlier visitors. The first offered a challenge more in its shape and faint push than in its motion across the galaxy. The second wore the classic outfit of a comet and kept its origin story vague. The third wears a compact shroud and a deeper tint and speaks with carbon dioxide first. This progression doesn't draw a clean line. It fills a page with varied sketches. Observations suggest our field guide is accumulating entries that broaden natural expectations rather than disrupt them. A single image helps me hold the origin question without strain, a modest compass laid on a star chart. Its needle still and its case scratched from use. The compass doesn't tell you which trail will be loveliest. It tells you which way is which. Our compass here is motion. It points to interstellar space, to a trajectory that belongs to the galaxy, not to the sun. The scratches are the dust's history. They tell us the object has travelled a great while and weathered many lights. The rest names of places and dates of departure remains beyond what the data can carry today. There is one more way to honour the question responsibly. We can outline what would change the origin conversation if it appeared later. A distinct family of minerals that don't match common comets would matter. A rotation period so odd that only a paper-thin shape could explain it would matter. A persistent acceleration that refused all natural tests would matter. It's likely that none of these will turn up based on what we've seen so far. Yet we can still keep the door cracked for real surprises. That is not because we need a twist, but because that is how honest watching works. The chapter's centre is gentle motion, tells us interstellar. Dust tells us seasoned. A few analyses lean toward an older galactic neighbourhood for the object's birth. Observation suggests those inferences cohere and leave room for refinement after the sun is behind us. You do not need to clutch any single claim tightly to sleep well. You only need to know that the broad picture hangs together with ordinary physics, and that the remaining uncertainties will shrink as more lines are added to the ledger. Let that compass rest for now. We've given the origin question a fair airing without asking it to do more work than it can. In the next chapter, we'll take up a different kind of question, the debated one, and hold it beside the measurements so the boundary between wondering and knowing stays clear. Chapter 10, the technological hypothesis. We begin in a calm frame. I'll lay the debated idea on the table. Then keep a hand on the evidence so you feel steady as we move. Every interstellar visitor raises the same pair of questions. What is it? And who made it, if anyone? The first is scientific in a direct way. The second requires more care, because it brushes a long tradition of story and hope. A recent exercise by a small group, led by a well-known voice, explored whether some of the observed behaviour could be read as technological. They framed the exercise as a calculation if you assumed certain things. Would a crafted object fit? The right way to handle that question is to let the measurements speak first, and to build the conversation outward from what the light and motion actually show. So we ask, gently, what a technological reading would need in order to rise above a thought experiment. It would need a persistent, directional push that could not be traced to jets or venting. It would need light behaviour that resisted natural dust explanations. It would need radio or other emissions that formed a coherent pattern beyond instrument artifacts, and it might need timing or targeting that suggested intent rather than happenstance. Observations suggest none of these thresholds have been crossed to date. It's likely that the motion remains consistent with gravity and modest outgassing, and that the light lines drawn by carbon dioxide and water speak the language of ices in sunlight. What if it were engineered rather than grown? Reassurance the data so far do not require that. And the simplest reading, an interstellar comet with unusual but natural properties, fits comfortably. It helps to take each proposed sign in turn. Start with motion, a clear, sustained acceleration that points in a fixed direction over many weeks, uncorrelated with solar heating or rotation, would be a strong flag. Instead, fits to the orbit. Keep finding that gravity carries most of the burden, with any small deviation sitting inside cautious limits. Those limits will tighten as the season advances and as the glare of the sun ceases to complicate the view. Observation suggests that the present arc does not contain a push we cannot place among natural causes. Now consider the light. A surface built of thin, reflective material could, in theory, behave in peculiar ways, but the spectra show the fingerprints of common volatiles, and the colour leans red in a way that season-long irradiation produces easily. Polarization curves dip and turn like those from airy aggregates rather than rigid panels. It's likely that the dust's behaviour, taken with the chemistry, explains the glow without reaching outside known materials. Signals from instruments that listen for narrowband transmissions are another oft-cited potential signee. Here the quiet news is good news. No techno-signature has been detected. A blank page is not proof of absence, but it is a reminder that the claim we heard something would need to vault a high bar of consistency, replication, and elimination of terrestrial sources. Observation suggests that teams will continue to listen in windows where the geometry helps, and the null result so far is part of the same calm pattern that runs through the rest of the data. Shape is the last piece many people reach for. A thin, broad geometry might show up as a distinctive rhythm in the light after the coma thins and the nucleus begins to modulate the brightness on a repeatable schedule. We are not there yet. It's likely that post-solar swing measurements will either reveal a familiar rotation signature or confirm that any variations are better tied to jets turning on and off as the body warms and cools. Even a thin object could mimic some of these signatures, which is why convergence from several lines like curve, polarization behavior, and motion is necessary before any striking claim earns its footing. I won't pretend the technological idea holds no appeal. Curiosity makes that idea bright, but your rest and the integrity of the story are better served by a checklist than a drumbeat. The checklist asks, does the observed behavior exceed the reach of ordinary models? Does it persist under different vantage points and instruments? Does it resist natural explanations even when we refine those explanations with new data? Observation suggests the answers right now come back as calm negatives. The idea remains a thought experiment that is waiting respectfully in the hall, while the data hold the floor. We can also ask what evidence would genuinely move the needle if it appeared later. A sustained acceleration that strengthens as the object turns away from the sun would be unusual. A light curve whose periodicity could not be matched by any combination of rotation and jet geometry would be unusual. A spectrum with lines that do not belong to common molecules and cannot be stitched together from simple fluorescence would be unusual. It's likely that none of these will arrive, but the promise here is that we will test them fairly if they do, because this series pairs every what-if with a handrail. Let's add one more. A spacecraft flyby, if it ever came to pass, would raise the signal-to-noise so high that surface texture, von structure, and mass could be constrained directly. That prospect is exciting in a practical way, not as a license for leaps. Until then, our best path is the one we're on spectroscopy during approach. Coordinated vantage when Earth's angle is poor, and careful post-sun photometry when the coma thins. Observation suggests that this program already points to an ordinary engine sunlight doing ordinary work on familiar ices and dust. Some people worry that even entertaining the engineered idea gives it more weight than it deserves. I think of it differently. Naming an idea and placing it between clear guardrails helps it stay in proportion. The guardrails here are measurements. They begin with the calm fact that the orbit behaves as gravity would expect. They continue with chemistry that matches a natural source. They extend through limits on any strange push that would betray hidden propulsion. It's likely that by the time Earth takes its longer turn at the eyepiece, those rails will be even taller. I keep one image at the back of the room so the mood never tips. Picture a balance on a clean table. On one side sits spectra, polarization curves, and orbit fits. On the other sits a single card that reads engineered. As the months pass, new sheets of paper, each a fresh measurement, land on the natural side. The card does not vanish. It just looks thinner beside the stack. That is how science quiets bold claims without scolding them. It adds weight where the evidence is, sheet by sheet. The center of this chapter is a single, quiet sentence that we can carry forward without strain. It's likely that the simplest reading is still the best reading, and that the object is a natural interstellar comet whose unusual notes are well covered by ordinary physics. The debated idea remains a hypothesis set aside for lack of need. If a need appears, we will see it together. If not, we will let the pattern stand. Let's leave the card on the table and return our eyes to the spectra. Chemistry has more to tell us as the sun warms the surface, and the next chapter listens closely to the balance between carbon dioxide and water as it unfolds. Chapter 11, Chemistry and Focus CO2 First. We'll keep natural causes first in line, and I'll walk you through the chemistry at a calm, even pace. Light lets us read what the coma is made of without ever seeing the core itself. Early on, when the sun was still a weak lamp from the comet's perspective, dust led the show in visible bands while the gas whispered. Then a clearer voice emerged in the infrared, and that voice belonged to carbon dioxide. Observation suggests the gas halo is dominated by carbon dioxide, with water and a handful of other companions present in quieter lines. That balance matters because it fits a simple, familiar rule. The ices that loosen earliest in weak sunlight are the ones that take the stage first. You and I can imagine the way these lines gather on a page. One arc stands taller and steadier, and beside it shorter arcs follow the same rhythm. The taller one is carbon dioxide, which answers mild warmth without much delay. The shorter ones belong to water and friends that wait for deeper heating. It's likely that as the comet drew inward, those quieter arcs began to brighten in step. Not as a sudden flare, but as a measured climb that models of sublimation have long outlined. The harmony here is its own reassurance. Early spectra also traced faint signatures linked to sulfur and carbon-bearing species that often ride with water and carbon dioxide in comets. None of those features demand anything exotic. Observation suggests the mix resembles what you might expect from a body that formed cold and stayed cold for a great stretch. Meanwhile, images tuned for dust show a compact, sunward-thickened glow, which is exactly how a gas-led coma carries grains outward when the sunlight hits one side more than the other. Chemistry and shape keep one another honest. I like to keep one gentle picture nearby when thinking about this balance. Imagine a kettle set on a stove at very low heat. The first hints of steam rise from the parts that answer earliest, while other pools stay quiet until the heat penetrates. That's what carbon dioxide and water are doing in this coma. Carbon dioxide begins to flow in the lightest warmth, and water follows as the upper skin warms through. Observation suggests that pattern here, and it sits neatly inside what we know from other comets that woke far from the sun and then brightened in stages. Let's place a careful anchor and leave it in clear view. Observation suggests that longer wavelength instruments caught carbon dioxide emphatically, and shorter wavelength and ultraviolet instruments found the fingerprints of water through its fragments as time went on. It's likely that both solid water ice and gas phase water are present, with the gas fraction rising as the days lengthened. That pairing ice in grains and vapour in the halo keeps the narrative grounded, because it explains how dust can look warm in colour while water signals grow in the spectra. Because our series promises to hold every curiosity with a handrail, we'll seat a what-if right here. What if carbon dioxide keeps the lead even near the sun, and water never quite takes centre? Reassurance that outcome would still fit natural explanations, including shallow heat penetration that lifts carbon dioxide from near the surface, while water locked slightly deeper answers more slowly. It's likely that the outermost layer has been processed by long radiation exposure, and in that kind of skin, different ices respond at different thresholds without needing any unusual mechanism. Another quiet clue sits in the way the gas halo spreads. When carbon dioxide drives the flow, the coma can look broad and even, with dust sizes skewed towards small grains that scatter light warmly. Observations suggest a reddish tint at visible wavelengths, which matches dark, seasoned dust with complex surfaces. That tint pairs well with a carbon dioxide-led halo because small, fluffy grains can be lifted gently and then hang in sunlight long enough to imprint their colour on the total light. Chemistry, texture, and colour nod to each other with easy agreement. We should also talk about how these measurements can mislead when taken alone. A single spectrum can be shaped by geometry, by the slit's position on the coma, by the way sunlight grazes one side and leaves the other in shadow. That is why the team stack many observations from different nights and instruments before they let a trend stand. It's likely that this stacking is what allowed the water signals to be seen clearly after their shy beginning, and it is certainly what gives weight to the claim that carbon dioxide led the dance. Patterns that persist under shifting angles matter more than one-night highlights, because this story lives in patience. The best tests are the ones that repeat after the sun is past its strongest influence. If a trend survives the glare's retreat, you know it more deeply. In this case, a consistent hierarchy of gas lines across changing geometry strengthens the simple picture rather than strains it. Observation suggests that the hierarchy holds, even as dust production rises and falls with illumination and spin. That resilience is a hallmark of ordinary physics doing what it does best. I'll keep the metaphor budget light and use a single framing image to carry the feeling of the spectra. Think of a woven cloth where one thread runs bold and the others weave through with quieter colours. The bold thread is carbon dioxide. The quieter threads are water, carbon monoxide, and minor species. Together they make a fabric you recognise the moment you touch it. There is no need to invoke a material unknown to the loom. It's likely that the weave will vary gently as heating reaches fresh patches, and that is exactly the kind of variation observers love to map. Now, because this series keeps debate near evidence, let's place the larger question once more without giving it more weight than it deserves. Could an engineered surface mimic this chemistry? In principle, one could imagine exotic materials outgassing in a way that fakes a natural mix. In practice, the lines we see and the way they rise and fall with sunlight fit a model that has carried dozens of comets safely. Observations suggest that a natural carbon dioxide engine, with water joining later, explains both the spectrum and the glow. It's likely that any bolder claim would need to climb over that simple explanation and clear it by a wide margin. The chapter's quiet center is a pair of sentences we can carry forward with confidence. Observation suggests that carbon dioxide leads the outgassing while water grows in strength as heating deepens, and the dust responds in a way that reddens the light and thickens the coma toward the sun. It's likely that this ordering reflects shallow heat penetration and a processed surface layer, which are ordinary outcomes of long travel between stars. These lines do not close the book. They give us a sturdy page to write on as more data arrive. Hold the fabric image for a moment, then let it rest. We've read the chemistry in a careful sequence and paired each surprise with a nearby reassurance. In the next chapter, we'll move beyond composition to the rhythms of motion that emerge after the sun is behind us, listening for shape and spin in the gentle rise and fall of light. Chapter 12, after perihelion shape, spin and jets. We'll let the light curve do the talking first, and I'll keep a steady hand on the natural explanations as patterns appear. When a comet rounds the sun and begins to pull away, its halo often thins enough that small, repeating changes in brightness come into view. Those changes can reveal rotation, because a lumpy surface or a patchy pattern of vents will modulate the light as the body turns. Observation suggests that this is the season when timing matters most, because a clear rhythm can tell us how fast the core spins and whether one side gives off more dust than the other. It's likely that a few photometric campaigns, stitched together from different longitudes, will be able to track these rises and falls over more than one cycle. The idea is simple even if the analysis is delicate. Imagine placing a finger on a soft pulse and counting the beats. Each beat, if real, should return on schedule. If the schedule drifts with sunlight, it may be a jet turning on and off. If the schedule stays firm under changing illumination, it may be the rotation of the nucleus itself. Observation suggests both effects can mingle, which is why teams cross-check any proposed period against changes in gas production and dust structure. A clean period that persists across geometry carries more weight than a fleeting hint seen under one angle, because this chapter invites a what-if. We'll bring it forward plainly and then place the handrail. What if the post-perihelion light curve hinted at a thin, broad shape that some would liken to a sail? Reassurance periodicity tests physical rotation first, and natural shapes can produce similar signatures, while jets can sculpt brightness in ways that mimic panel-like behavior over brief spans. It's likely that any claim of an unusually thin geometry would need convergence from several lines light curve, polarization behavior, and sustained motion, and that bar is high by design. The presence or absence of a small non-gravitational push will be tested again during this phase. Jets can produce tiny accelerations if they favor one hemisphere, or remain active at a fixed orientation. Observation suggests that current fits place only upper limits on any such push, and those limits will sharpen as the arc lengthens and the coma quiets. It's likely that even a small detected drift would first be weighed against jet geometry and rotation, because those natural causes have matched many comets before this one. Mass and size remain the quiet unknowns beneath these tests. We hold a ceiling on the cause scale from high-resolution imaging, and we work backward from activity to infer what combinations of size and density are plausible. The degeneracy is real. A modest body with vigorous vents can look like a larger one with gentler activity. Observations suggest that tying a firm rotation period to the model can trim that uncertainty, because a spin rate that is too fast for a thin object would rule out extreme geometries without a single picture of the core. It's likely that this is where subtle timing pays an outsized dividend. There's a reason observers love this part of the arc. After perihelion, the glare softens and the tail unwinds into finer structure. Striations appear where separate jets waft dust into distinct lanes, and those lanes can point back to active regions on the surface. The lanes also respond to rotation, sweeping a slow fan that repeats. Observation suggests that a compact, sunward-thickened coma will still show this behavior once the overall brightness drops a little, which makes the compact visitor a sharper test of jet mapping than a broad. And if he is one, I'll use a single image to hold the feel of these patterns without getting tangled in details. Think of a wind chime seen from a distance. When the breeze rises, Certain notes ring and fade in a rhythm you can learn if you listen long enough. The light curve is that rhythm, and each jet is a chime. You don't need to stand under the chimes to sense the wind. You watch the pattern repeat. It's likely that one or two dominant jets will write most of the melody, with smaller ones adding texture on better nights. A practical note belongs here as well. Coordinated timing across observatories reduces ambiguity because it fills gaps and catches long periods that a single sight might miss. Observation suggests that such coordination is already part of the plan, with handoffs scheduled as night sweeps across the globe. The result is a light curve that looks less like a dotted line and more like a smooth path you can trust. When that path is compared to gas production and polarization changes, the model of shape and spin becomes a joint solution rather than a single instrument guess. The technological hypothesis threads through this phase too, and it should be handled with the same calm rules. A thin, reflective geometry could, in theory, show a light curve with sharp peaks and flats unlike a rough, compact body, but jets can sharpen peaks, and rotation can flatten stretches, and the interplay between them is rich enough to mimic many profiles. Observation suggests that only a profile that resists these natural explanations across changing angles would call for a bolder idea. It's likely that the profiles we see will lean toward the familiar, because the rest of the evidence has leaned that way from the start. As for safety, this chapter offers the same reassurance the others did. The missed distance remains generous, and the refinements that come from better timing do not pull the path toward threats. If anything, they trim fuzz from the curve and make the projection cleaner. Observation suggests that orbit updates during this phase will be small, and that their main effect is to reduce uncertainty rather than redirect the line. It's likely that listeners who check the sky summaries will see words like consistent and steady more often than anything that raises the pulse. One more modest gain often arrives here. With a period in hand, polarization measurements can be phased to the rotation, which lets observers test whether dust properties vary with location on the surface. If the deep dip in the polarization curve were linked to a particular region, it might wax and wane as that region turns into view. Observations suggest that most comets show only gentle modulation of that sort, and if this traveller follows suit, the area aggregate picture will be reinforced rather than shaken. It's likely that we'll come away with a portrait of a small body wearing a processed skin and exhaling along a few preferred lines. Let the feeling of this phase settle. The light rises and falls with a rhythm we can measure. The jets write faint lanes into the dust, and the orbit trace tightens in a way that clarifies rather than alarms. Observation suggests non-gravitational effects remain bounded and small if they appear at all, and it's likely that a natural rotation and jet model will carry the day. If a deeper oddity emerges, we will test it under better angles and steadier nights before letting it change our minds. Hold that rhythm a moment longer, then let it fade to a comfortable hush. In the next chapter, we'll tune our ears to a different channel and listen for signals that would stand apart from sunlight and dust, while keeping the guardrails high and the mood unhurried. Chapter 13, Listening Quietly, Signals and Claims, was still on steady ground, and I'll keep the listening gentle so every test feels calm and clear. When people hear about a visitor from beyond our sun's family, they naturally wonder if it might speak. The instruments we use for that question are built to notice order hiding in noise, and they do so with a patient discipline that leaves little room for leaps. A radio dish doesn't ask for a story. It checks for narrow, repeating tones that nature rarely composes on its own. Optical and infrared searches add their own forms of watchkeeping, looking for flashes or structured lines that would stand apart from sunlight, dust, and gas. Observations suggest that, to date, nothing in these channels has risen above the careful thresholds set for a true signal. That simple sentence anchors the mood as we continue. Everything we have heard so far sounds like the sky doing what skies do. Listening is a craft filled with traps we already know. Earth is noisy, even in quiet places. Satellites blink and sweep. Aircraft talk to towers, and older equipment can surprise you with its own inside voices. That is why teams follow a checklist point. Record, offset, repeat, and then ask a partner instrument to try the same thing. It's likely that any whisper you've seen mentioned in passing was the kind that fades when the test is run again under a different angle or at a different hour. Repetition, in this domain, is not just a virtue, it's the gate that every claim must pass. Another class of claim appears in tidy, confident threads on line alignments, coincidences, echoes of older mysteries. A visitor passes a plane in the sky, A historic signal once came from a nearby patch. A calendar date lines up with an orbital milestone. On their own, these pairings carry no weight. Observations suggest there is no established literature connecting this object to any past radio oddity or special geometric alignment that would imply intent. If you place one idea beside the measurements sit there quietly, unchanged. It's likely that the best way to treat such side paths is with a nod and a return to the work, because the work is how we keep the proportion right. Still, we can honour the allure without letting it grow. Imagine a control room in a deep, late hour. The dish has been tracking for a while. The spectrum marches across a screen as a field of small, flickering brightness. If a line lifts and holds, the room doesn't cheer, it checks. Instruments swap roles, frequencies step to a clean nearby band. The source is nudged off and back. The test is run again a night later. If the line fails the sequence, it lands in a folder marked with ordinary explanations. Observation suggests that this is where most bright roomers go to rest, and that is a helpful rest for everyone listening with you now. We can also ask what would count as meaningful in this space. A narrow band carrier that keeps its pitch through the Earth's rotation and persists under a changed line of sight would matter. A repeating burst schedule that survives scrutiny and shares no signature with known human traffic would matter. A structured optical pulse that matches a schedule seen in radio under coordinated conditions would matter. It's likely that none of these will appear, and that is not a disappointment. It is the calm continuation of a pattern in which natural explanations stand tall, while extraordinary ones wait quietly for evidence they do not yet have. Because what if belongs beside reassurance? Not far from it. Let's place it openly. What if a transmitter were present? Either faint or intermittent. Riding the coma like a hidden lantern, reassurance-coordinated searchers are already setting strict limits on such possibilities, and null results are information that narrows the field. The absence of a tone tonight is not proof of absence forever, but it is exactly what you expect when an interstellar comet breathes and reflects sunlight with no intention beyond chemistry and heat. Observations suggest that the radio and optical ledgers remain blank where a techno-signature would write its name. It's likely that the quiet will continue as more instruments take their turns. We should also talk about the temptation to treat coincident timing as a clue. The object's approach near a seasonal date, a pass not far from a planet, the way an angle improves just as a facility comes online. These are the everyday coincidences of orbital dynamics and human scheduling. The sky moves on its mechanics. We move on ours. When they land together, the overlap can feel scripted, but it is not a script. It's the natural mesh of many clocks. Observations suggest that the Mars-side vantage that helps some observations is a gift of geometry, not an appointment kept by the visitor. It's likely that the clearest path forward is to enjoy the fortuity and still let the measurements stay in charge. A quieter channel of listening happens in the chemistry itself. If we found spectral lines that didn't belong to known molecules, that would be a different kind of antenna perking up. But the lines we see belong to the family we expected carbon dioxide first. Water rising, a handful of companions that fit a cold origin and sunlit wake-up. A spectrum can surprise you with ratios and with timing, and we've already seen a ratio that prefers carbon dioxide earlier than water. That surprise lives in the natural story comfortably. Observation suggests that any true outlier line would need to pass the same replication tests as a radio tone. It's likely that this is where the quiet will continue to be the rule. Because I want your mind to rest, I'll keep our images simple. Think of a notebook where each page is a night, and each night ends with short entries written in the same neat hand, no carrier, no pulse, no structured line beyond the usual. The repetition is not boring, it's soothing. It lets the larger picture gather without being poked into life. If a night ends with a different sentence, a second and third page are written before anyone considers raising a flag. That rhythm protects the story from spikes of attention that would otherwise yank it away from what the object itself is doing. Another claim deserves a gentle place near the back of this chapter, targeting if the path crosses a planet's orbit or passes above a well-known plane. Some will ask if the motion aims at anything in particular. Here the remedy is simple geometry. The visitor's path was set long before it came near us, and the crossings that look like aiming are the kind that thousands of comets trace without intent. Observations suggest that a wide miss remains the rule, and that's the only kind of targeting we welcome in these stories. It's likely that this reminder will feel repetitive by the end. And repetition is the point. Before we close, 2 anchor lines to carry forward. Observations suggest that no technosignature has been detected from this visitor to date, and it's likely that continued monitoring will add more null entries to that ledger without changing the basic reading. Observations also suggest that claims of special alignments remain unsupported in the peer-reviewed record, and it's likely that they will fade as the measured timeline fills with steadier notes. Those two lines do not argue. They sit like small stones at the edge of a path, marking the safe way through. Let the quiet be a comfort rather than a tease. We listened. We compared. We asked partners to listen with us. And the result fits the same frame as the rest of the evidence, a natural comet. Unusual in some endearing ways, uninterested in saying anything beyond what sunlight draws from its ices. In the next chapter, we'll step back from the instruments and gather the shared view, how the community is weighing the data, and why the working consensus keeps the mood unhurried. Chapter 14, The Working Consensus. We're still in calm waters here, and I'll keep the summary steady so the centre holds while we look around. Consensus is not a vote. It's an echo that builds when many careful measurements point toward the same table. With this visitor, that table holds a few plain statements that have absorbed the bumps of new data without tipping. Observations suggest that the trajectory remains well described by gravity, with any small outgassing nudges staying inside cautious limits. Observations also suggest that the composition tilts toward carbon dioxide with water growing in time, and that the dust is dark and porous, likely seasoned by a long journey. It's likely that these statements will still be true when the last charts of this apparition close. Even if the margins tighten, the community's mood has been shaped by three anchors that we can name without pages of equations. The first is safety. The geometry keeps Earth comfortably distant, and the modelled mist stays generous even as the orbit is refined. The second is presentation of visible coma and a compact, sunward-thickened glow that looks like many comets we already know. The third is behavioural wake-up order that fits the physics of shallow heating and processed surfaces. Put those together, and you have a story that holds across telescopes, wavelengths, and vantage points. Comparisons helped get us here. The first interstellar visitor taught humility about shape and subtle forces. The second reminded us that the classic comet script can arrive from beyond our sun. The third now broadens the set without breaking it. Observations suggest that the reddening is stronger, and the polarization twist is deeper than average. Yet they land in the same room as many natural cases. It's likely that the unusual but natural phrase you hear is not a hedge, but a fair account of where the weight of evidence sits. Consensus also benefits from the quiet weight of null results. We did not hear narrowband radio tones that repeated across hours and angles. We did not see structured optical pulses that rose above the test of offsets and partners. We did not find a persistent push that refused every natural explanation. The absence of these is not a drumbeat. It is the soft hum that lets the melody chemistry, light, and motion be heard without distraction. Observation suggests that the hum will continue, and that's a good thing for your rest tonight. None of this means we are done learning. It means we have a frame that can hold new details without cracking. That frame expects a few refinements after the sun is behind us. The coma should thin, brightness variations may reveal a rotation rhythm, and polarization tied to phase can test whether dust properties change with region. It's likely that each of these threads will tighten the portrait rather than redraw it. But even if something odd appears, the oddity will have to climb over a careful array of measurements that now agree more than they disagree. I like to hold a simple image when I think about this stage, a clean table with a growing stack of pages, each with one line added in the same neat hand. The early pages carry size limits and outlines. Later ones hold spectra that say carbon dioxide first and water next. A set of pages near the middle list the geometry windows and the handoffs between instruments. Near the top, a few sheets record nulls from radio and optical searches. Observations suggest that when you flip through the stack, the story reads in one voice. It's likely that the remaining pages will keep that voice steady, because consensus attracts strong feelings, both comfort and suspicion. It's worth saying what it isn't. It isn't a shield against revision. It isn't a pledge to never be surprised. It's a current best reading shaped by repeated checks that weathered small contradictions and kept the parts that held up. When people imagine a dramatic twist, they often forget what it would have to move. Not just one measurement, but a lattice orbit fits, chemical lines, dust behavior, polarization curves, and null searches. Observations suggest that this lattice is robust, and it's likely that a twist would chip it at the edges rather than break it cleanly. Let's place 2 quiet sentences you can lean on after this chapter ends. Observation suggests that the working picture an interstellar comet with a compact coma, a reddish dust veil, and a carbon dioxide lead fits all major lines of data so far. It's likely that even with fresh observations after the glare fades, the centre of that picture will remain still while details sharpen around it. Those sentences do not demand trust. They report on trust earned by consistency. Consensus also has a practical benefit that I hope eases your mind. It sets priorities for the remaining time. Well, if we're not chasing a wayward push or an odd transmission, we can spend the hours on photometry that pins down rotation, on spectroscopy that traces the balance between gas species as the heating changes, and on polarimetry that maps dust properties across phase. That is how you use a season wisely. You align effort with the questions most likely to teach. Because every chapter in this series places a small what-if beside a handrail. We'll do it here too. What if a late-season acceleration appears and lingers in a direction that refuses the usual jet pattern? Reassurance, the first checks will test rotation, vent geometry, and phase ties, and only after those pass would any bolder claim be weighed. It's likely that natural causes will keep answering, because they have answered well up to now, but if something more is needed, it will have to bring coherence. Not just surprise. I also want to underline how consensus helps with communication. It lets agencies and observatories speak in one calm voice to people who do not follow every preprint and instrument log. The voice can say, without drama, that the object remains far from Earth, that its path is steady, that its chemistry is familiar in order, and that its dust tells a story of long travel. Observation suggests these messages already shape the public mood, and it's likely that they are doing the quiet work of turning anxiety into interest. The best part of a steady view is the room it leaves for wonder of the right kind. Wonder does not need sharp turns. It needs clear windows and time. This vista gives us both. It crosses, it speaks in light, it keeps its distance, and it adds a line to the growing field guide of things that wander between stars. If another traveller arrives with different quirks, we will have this chapter's lessons ready to hand. Compare carefully. Listen well, and let ordinary physics set the floor. Hold that thought as we close for now. The shared view is steady. The evidence agrees more than it argues, and the remaining work is shaped, not frantic, in the next chapter. We'll look ahead to the windows that are opening and the tests that can still refine what we know, keeping the same measured pace while the season turns. Chapter 15, Windows Ahead and Possible Tests. We're still in a friendly geometry, and I'll keep the plan simple so the next steps feel unhurried and clear. Windows decide what we can learn next. They open and close for reasons that have nothing to do with impatience, and everything to do with where the sun sits and how the comet moves. Observation suggests that after the bright weeks pass, Earth's angle improves, and our ground telescopes begin to regain a cleaner view. It's likely that this shift will arrive as the glare drops and the coma thins, revealing patterns that were there all along but hidden by light. When that happens, the most valuable measurements are not flashy. They are steady photometry to track brightness rhythms, careful spectra to watch chemistry rebalance, and polarimetry at several phase angles to test dust texture against earlier inferences. Think of the schedule as a path marked with quiet milestones. First, ground-based observatories in both hemispheres share the load so no gap stretches too long. Then, instruments tuned to different bands take turns optical for light curves and dust structure, infrared for gas lines that show how carbon dioxide and water trade places in strength, and ultraviolet where fragments of water speak softly. Observation suggests that coordinating these turns reduces ambiguity in a way that a single heroic campaign never could. It's likely that the combined record will look like a smooth, continuous line instead of a dotted one, which is exactly what we need to settle lingering questions about spin, jets, and the relative weight of different gases. A few vantage points away from Earth remain important while our angle catches up. Mars-based orbiters and deep space telescopes that can schedule longer stares without day-night interruptions extend the timeline cleanly. The geometry from those places is kinder in some phases, and kinder geometry becomes kinder data. Observation suggests this multi-site approach has already tightened the orbit and refined the activity curve. It's likely that the same cooperation will carry through the months ahead, making each new line easier to place on the same ledger without fuss. Now we place a practical goal near the top of the list, a reliable rotation period. If the post-sunlight curve shows a repeating rise and fall that persists across nights and across filters, We can fit a spin rate and look for secondary modulations tied to jets that turn on and off. That one period unlocks several doors at once. It constrains shape indirectly. It anchors jet geometry models, and it helps translate photometric changes into physical causes without reaching. Observations suggest that compact Comet like this one can still write clear rhythms once the brightness calms. It's likely that a handful of long, patient nights will give us the pulse we need. Spectroscopy in this next window is about balance more than discovery. Earlier, carbon dioxide spoke first, water joined later. The question now is how the duet sounds as heating eases. Do the lines settle into a steady proportion, or does one fall back faster than the other? Observations suggest that carbon dioxide may remain a strong player even as the distance grows again, while water lingers at a reduced but distinct level. It's likely that such trends, if confirmed across instruments, will strengthen the view that shallow heat penetration and a processed skin explain the ordering without fuss. Polarimetry returns for a second act in this window because angle matters to that measurement more than brightness does. We will draw the curve again and watch where the sign flips and how deep the dip remains. If the curve shifts slightly with phase and still keeps its overall shape, the area aggregate picture for dust grains gains credibility. Observation suggests the earlier dip was deeper and the crossing earlier than is common. Repeating that behaviour post-sun would tie the chapter close neatly. It's likely that any changes will be gentle, reflecting altered grain populations as different parts of the surface exhale and rest. Because this series pairs questions with handrails, let's see to what if that appears in conversations when windows open. What if a spacecraft were retargeted for a pass that could settle everything at once? Reassurance proposals can be healthy thought exercises, but observations suggest these ideas remain conceptual rather than scheduled operations, and the current plan already provides strong tests from telescopes near and far. It's likely that even without a flyby, the combination of rotation timing, spectral balance, and polarimetric curves will tell us what we need to know about natural versus exotic causes, and will do so with room to spare. The watch for non-gravitational effects continues quietly through this phase. The goal is not to prove a negative, but to keep the limits honest as the coma evolves. Orbit fits will be rerun with fresh astrometry, and the natural first checks jet direction. Rotation phase and illumination changes will be used to interpret any small shifts. Observation suggests that current departures from a gravity-only path sit inside cautious bounds. It's likely that those bounds will tighten as the arc lengthens, reducing the space in which exotic explanations could hide without contradicting multiple lines at once. A secondary benefit of these windows is practical housekeeping for the size and mass picture. With a rotation period in hand, models can flag combinations of size and density that would be unstable. A thin, extensive geometry would have to live within limits that rotation and material strength allow. Observation suggests the nucleus remains unresolved, which keeps the size a ceiling rather than a measurement. It's likely, though, that combining photometry, polarization, and gas production rates will prune the more extreme shapes without needing to see the body directly. Community coordination is itself a test of good practice, and this is the season when it matters most. Observatories will pre-announce blocks of time, share calibrations, and align their reductions so the curves can be placed on the same baseline. Observations suggest that partnerships like these helped with the earlier interstellar visitors and paid dividends in clarity. It's likely that the same playbook will turn a stack of independent results into one coherent view that is easy to explain without jargon. If you feel your thoughts drifting as we plan, let them drift and land softly. The schedule is on the instrument teams now, and their rhythm is unhurried by design. You and I can simply note the key beats Earth's view cleans up. The light curve seeks a stable period. Chemistry finds its post-sun balance. Polarization redraws the curve at kinder angles, and orbit fits absorb the new points without strain. Observations suggest that none of these beats threaten to change the safety picture. The misdistance remains generous. It's likely that the words you'll hear again and again during this phase are consistent, steady, and refined. One modest image can hold all of this without fuss. Picture a wall calendar with 3 gentle circles, one for the return of Earth's view, one for the planned photometry runs, one for the coordinated spectra, no exclamation marks. No dramatic arrows, just small circles and neat notes in the margins. That is how a good season looks from the inside. It trades rush for rhythm and surprises for converging lines. If a late season surprise appears a small push that persists beyond jet explanations, a line in the spectrum that refuses a familiar label. It will be tested in this framework first. That means repeating under new angles, phasing against rotation, and checking partners for agreement before any claim changes category. Observation suggests that most surprises soften under that treatment and find a home among ordinary causes. It's likely that this one will too, and if it doesn't, we'll know it in a way that earns attention rather than borrowing it. Let that plan rest. Open windows or invitations, not alarms, and the best work they allow is patient, layered, and kind to the truth. In the next chapter, we'll knit everything together into a simple decision framework you can carry what counts, what doesn't, and how to keep your footing if a new result tries to pull you faster than the evidence does. Chapter 16, A Calm Decision Framework. We'll set gentle guardrails first, and I'll keep each step close to the evidence so your footing stays steady if anything new arrives. A framework is a promise you make to your future self. It says that when attention spikes, you'll let checks lead and keep conclusions on a leash. For this visitor, the framework is not elaborate. It rests on 3 pillars: motion, light, and consistency across vantage. Observation suggests that the motion to date is well described by gravity, with any small outgassing nudges living inside cautious limits. Observations also suggest that the light color, spectrum, and polarization matches dust and ices shaped by long travel and shallow heating. It's likely that future measurements will shade these pillars rather than replace them, which is why they belong at the center of our decision guide. Start with motion. The test is simple. Do we see a persistent directional acceleration that cannot be traced to jets, rotation, or illumination changes? To answer, we phase any suspected drift against the spin, compare nights with similar geometry, and ask whether the sign and strength of the departure hold as the object moves. If a candidate push shrinks or changes direction with the heat cycle, jets are the first explanation. Observation suggests that current upper limits already reassure. No strong, stubborn drift has demanded new physics. It's likely that post-sun fits will tighten those limits, making the natural readings stronger by quiet increments. Move to light. The spectrum tells us which gases are present and in what relative strength. The color tells us about dust. The polarization curve tells us about grain texture. The question here is not, is any one feature unusual? The question is, do multiple light-based diagnostics resist a shared and natural explanation? If carbon dioxide leads while water grows later, and if the dust is dark and porous and produces a deeper dip with an early crossing in polarization, that triad fits neatly inside known scattering and sublimation physics. Observation suggests exactly that pattern. It's likely that continued spectra and curves will confirm it under new angles. Consistency across vantage is the quiet hero of this framework. A claim that appears in one set of conditions but fails to repeat under a different angle is a warning, not a wonder. That's why coordinated observations matter. They give us the power to say, this holds when we look from here and from there. If a purported anomaly survives those moves, it gains weight. If it doesn't, it loses altitude and returns to the pool of ordinary variation. Observation suggests that earlier rubrics like this one calmed debates around other visitors by favoring convergence over excitement. It's likely to do the same here. Now we can place the chapter's required what-if where it belongs. What if a small, directional acceleration appears later and seems to linger? Reassurance jets can mimic subtle pushes, and the first checks will model out gassing tied to rotation and solar heating before any exotic cause is weighed. It's likely that these natural models will explain small drifts if they appear, because they have done so for many comets under similar circumstances. If, after that, a stubborn residual remains, the framework requires that at least 2 other lines like behavior and cross-vantage consistency agree before any bold interpretation is entertained. We also keep a simple policy for signals. A narrow-band radio tone or a structured optical pulse must persist under instrument changes, survive offset tests, and be seen by partners who are blind to local interference. 1 detection is an invitation, 2 are a hint, 3 in coordinated fashion are the beginning of a case. Observations suggest no such signals have been confirmed to date. It's likely that the ledger will continue to collect quiet no entries, which are not empty. They narrow the room for extraordinary claims to hide. Shape and spin fit into the framework as tools that weigh plausibility. A rotation period that is clean, and a light curve shape that can be modelled with jets, and a compact nucleus make extremely thin geometries less likely. If someone proposes a sail-like body, the curve has to refuse those natural fits broadly. Not barely. Observation suggests that post-sun photometry will give us this leverage soon. It's likely that the results will point toward a modest body with a processed skin and a few favoured vent lines, which is what the rest of the evidence has whispered all along. Because frameworks can be misused as shields, let's underline what this one does not do. It does not say never. It says first things first and several things together. It does not dismiss interest in alternatives. It demands that alternatives earn their place by clearing higher bars than a single curve or a single night. That's not stubbornness. That's care. Observation suggests that when communities adopt such rules, dramatic claims arrive less often but land more firmly when they do. It's likely that if a true anomaly appears here, it will be stronger for having passed through this gate. 2 small, factual anchors belong in your pocket as you use this guide. Observation suggests that no technosignature has been detected from this object, and that repeat searches under better geometry continue to return null results. Observations also suggest that the trajectory remains safely distant from Earth, and is consistent with gravity and modest venting. Those anchors are not conclusions. They are conditions that every new claim must respect unless replaced by heavier evidence. I like to keep one quiet image nearby so the framework never feels like homework. Picture a clean table with 3 trays. One is labelled motion, 1 light, 1 consistency. A new result arrives and you set it first on the motion tray. Does the orbit require more than gravity and jets? Then you move it to light do spectra, colour, and polarization agree on natural dust and ice. Finally, consistency. Does it hold under new angles and new instruments? If a paper slips off any tray, it returns to the stack for revision. This is not a game of skepticism. It is a way to make sure you are carrying evidence, not headlines. And because every quiet rule needs a gentle exception path, we note what would constitute a true pivot, a sustained, orientation-stable acceleration that survives jet modelling and grows when natural pushes should fade, a spectrum that carries lines alien to known molecules and repeats across instruments, a light curve whose periodicity and shape cannot be reconciled with rotation and jets across seasons. It's likely that we will not meet these thresholds here, but if we do, the same framework will help us name the change without overreaching. Let the framework settle in your hands like a small tool you can fold and pocket. When a new plot appears, you'll know where to place it. When a claim makes rounds, you'll know what questions to ask kindly. None of this steals the wonder of an interstellar traveller crossing our sky. It preserves it by keeping the story honest. Observation suggests that the simplest, natural reading has earned its place through many converging lines. It's likely that the closing pages of this apparition will keep that reading steady, even as details sharpen and small mysteries are resolved. Rest with that for a moment. We've walked the windows, set the guardrails, and given ourselves a way to weigh whatever comes next without losing our balance. In the closing segment, we'll gather the softest threads a distant path, a reddish glow, a chemistry that speaks in familiar tones and offer one quiet breath to carry with you after the lights go down. The teardrop glow stays compact, the nucleus still shy, and the chemistry keeps its promise: carbon dioxide first, water growing. Oh, speaking softly as the days turn, we checked for narrow voices on the airwaves and found none. We watched the path and saw a clean crossing, gravity doing the carrying with only modest breathing from jets. Observations suggest the dust is dark and porous, a texture that fits the deep polarization dip and the warm colour in the visible bands. It's likely that this is the look of long travel between suns rather than anything engineered for effect. Cross the months, the rhythm held, pre-discovery frames stretched the timeline, the orbit steadied, and windows from Marside vantage and space-based instruments filled gaps while Earth waited for a kinder angle. Spectra remained a woven cloth with a bold carbon dioxide thread and water brightening later. Polished checklists kept the listening on his point. Record, offset, repeat. Then ask a partner to try again, the ledger filled with calm entries, no carrier. No structured pulse, nothing that needed to climb over ordinary physics. We also kept a simple decision framework close at hand. Motion first does a persistent, directional push survive jet modelling and rotation ties. Light second do spectra. Colour and polarization resist a shared natural reading. Consistency last as any hint endure under new angles and new instruments. Observation suggests the answers never left the quiet lane. It's likely they will stay there as the coma thins and the post-sunlight curve reveals rotation in a modest, repeating rise and fall. Safety never left the centre. The distance remained generous. and the models agreed as the arc lengthened. That steadiness gave room for the best kind of wonder, the kind that arrives as patience rather than surprise. If a late-season quirk appears, the same guardrails will greet it, repeat the test. Change the angle, ask a partner to look, and seat any claim beside the measurements rather than ahead of them. I'm closing the loop with something small and real that holds the whole mood, a dim amber nightlight glowing at the floor of the observatory corridor, guiding quiet steps toward the dome while the printer hums out one more spectrum. That little light is the promise of this story. The watch continues at a human pace. The traveller keeps its distance. And ordinary physics carries almost all the weight, sheet by sheet. If you'd like, you can drift now, and I'll keep a gentle watch as the next pages write themselves.